Cybersecurity refers to the practice of protecting systems, networks, and data from digital attacks. It encompasses technologies, processes, and practices designed to safeguard devices, networks, and data from unauthorized access or cyber threats. Cybersecurity is essential in today's digital age to protect sensitive information and ensure the integrity of systems. Cyber attacks are increasing in frequency and sophistication, posing significant risks to individuals, organizations, and governments. A successful cyber attack can result in financial losses, reputation damage, and legal consequences. Implementing robust cybersecurity measures is critical to mitigate risks and safeguard against potential threats. Common cyber threats include malware, phishing attacks, ransomware, and denial-of-service (DOS) attacks. Threat actors can be individuals, criminal organizations, or nation-states with various motives, such as financial gain, espionage, or disruption. Understanding the evolving threat landscape is essential for developing effective cybersecurity strategies. Confidentiality ensures that sensitive information is only accessible to authorized users. Integrity focuses on maintaining the accuracy and consistency of data throughout its life cycle. Availability ensures that systems and data are accessible to users when needed, minimizing downtime and disruptions. Cybersecurity frameworks provide a structured approach to implementing and managing security controls. Common frameworks include NIST Cybersecurity Framework, ISO/IEC 27001, and CIS controls. Organizations can use these frameworks to assess their cybersecurity posture and identify areas for improvement. Access controls limit user access to systems and data based on their roles and permissions. Encryption protects data by converting it into a secure format that can only be accessed with the appropriate decryption key. Intrusion detection systems monitor network traffic for suspicious activity and potential security breaches. Network security focuses on protecting the integrity and confidentiality of data transmitted over a network. Firewalls, intrusion prevention systems, and virtual private networks, VPNs, are common network security technologies. Regular network monitoring and vulnerability assessments are essential for identifying and mitigating security risks. Endpoint security involves securing individual devices, such as computers, smartphones, and tablets, from cyber threats. Antivirus software, endpoint detection and response (EDR) solutions, and mobile device management (MDM) tools are key components of endpoint security. Endpoint security measures are essential to prevent malware infections and unauthorized access to sensitive data. Cloud security focuses on protecting data, applications, and infrastructure hosted in cloud environments. Encryption, access controls, and data loss prevention (DLP) are critical for securing cloud-based resources. Cloud service providers and organizations share the responsibility for implementing and maintaining effective cloud security measures. Incident response is a structured approach to addressing and managing security incidents, such as data breaches or cyber attacks. The incident response process typically involves preparation, detection, containment, eradication, recovery, and lessons learned. Timely and effective incident response is essential for minimizing the impact of security incidents and restoring normal operations. Security awareness training educates employees about cybersecurity best practices and potential threats. Phishing simulations, security policies, and regular training sessions help raise awareness and promote a security-conscious culture. Well-trained employees are a critical line of defense against social engineering attacks and other cyber threats. Multi-factor authentication requires users to provide multiple forms of verification to access a system or application. Common factors include passwords, biometrics, security tokens, and one-time passcodes. MFA enhances security by adding an extra layer of protection against unauthorized access. Security hygiene refers to the best practices and habits individuals and organizations should follow to maintain cybersecurity. Regularly updating software, using strong and unique passwords, and enabling security features are examples of security hygiene practices. Good security hygiene helps prevent common cyber attacks and vulnerabilities. Vulnerability management involves identifying, prioritizing, and remedying security vulnerabilities in systems and applications. Vulnerability scanning tools, patch management processes, and security assessments are key components of vulnerability management. Proactive vulnerability management is essential for reducing the risk of exploitation by threat actors. Data privacy regulations, such as GDPR and CCPA, govern how organizations collect, store, and process personal data. Compliance with data privacy laws requires implementing appropriate security measures and safeguarding individuals' privacy rights. Data privacy and compliance efforts help build trust with customers and avoid regulatory penalties. Security incident reporting is the process of documenting and reporting security incidents to the appropriate stakeholders. Incident reports should include details such as the incident type, impact, root cause, and remediation actions taken. Prompt and accurate incident reporting is essential for understanding security incidents, improving incident response, and preventing future incidents. Cybersecurity automation involves using technology to streamline and automate security processes and tasks. Automated security solutions can help detect and respond to threats faster, improve efficiency, and reduce human error. Automation tools such as security orchestration, automation, and response (SOAR) platforms can enhance organizations' cybersecurity capabilities. Artificial intelligence, AI, machine learning, and blockchain are emerging technologies being used to enhance cybersecurity. AI and machine learning can help analyze vast amounts of data to identify patterns and anomalies indicative of cyber threats. Blockchain technology offers new possibilities for secure data storage, identity management, and decentralized security solutions. Regularly update software and systems to patch security vulnerabilities. Use strong, unique passwords and consider implementing password managers. Backup data regularly and test restoration procedures to ensure data recovery in case of a cyber incident. Cybersecurity is a dynamic and evolving field that requires constant vigilance and proactive measures to protect against cyber threats. By implementing robust security measures, staying informed about the latest threats, and fostering a culture of security awareness, organizations can enhance their cybersecurity posture. Remember, cybersecurity is everyone's responsibility, and together we can work towards a safer and more secure digital environment.